I want to offer to you here a systematic method for factoring trinomials because I do not like the guess and check method. I mean, it's okay, but if your leading coefficient is different from 1, it suddenly becomes a lot harder. In particular, if that leading coefficient is not prime. And I do it, my method is different than any other method that I have ever seen anyone do. I've never seen it in a book, and I think that it's pretty smart. So let's start first by looking at how we would find the product of two monomials. This way we can see how this system is working. So I will have this as one of my monomials, and the other can be 2x minus, let's say, 3. Then we want to multiply these together. Do that however you know how. We would wind up with, actually, let's just do it by the acronym FOIL, right? Except for what I'm going to do is when we multiply the first two terms, I'm not going to simplify it, right? I'm just going to say minus 6x times 2x, and that's f for in FOIL, right? And then you got your outer terms, so we'd have a minus 6x times a minus 3, and then you got your inner terms, so that'd be 11 times 2x, and then you got your last two terms, so it's 11 times negative 3. All right. We are going to come back to this writing. So put a pin in that. Now I'll go ahead and simplify everything. So we'd have a minus 12x squared, and then we'd have 18x, and then another 22x, and then finally minus 33. Okay, we are also going to come back to this step here in a moment once we start studying our algorithm. Finally, you would combine like terms and wind up with the trinomial of minus 12x squared plus 40x minus 33. All right, now potentially this could be a trinomial that you would have to factor. And let me tell you, just staring at that thing and guessing and checking, for a lot of my students, is hard. It's hard for me to just from right here at this trinomial plop down a pair of parentheses and try and fill them in. I don't even want to bother with that. Instead, we're going to use this system. So let me show you now. Okay, this was our polynomial. And what we want to do, I tell my students so they'll help remember what to do. I'd say let's use the method of the A's and the B's. We're going to use the method of the A's and the B's. Now, this is a nonlinear, or it's about to be a nonlinear system of equations. And my claim is that we should study this other problem in order to figure out how to factor this guy. Okay? And what we want to do is we want to find an a times a b that is equal to the product of the leading coefficient and the constant. And I want to find an a plus a b that is equal to the constant on the x term. If we can find such an a and a b, then we will come back over to our original polynomial and we will write it where instead of having 40x, we will have ax plus bx. Then we will be guaranteed that this rewriting of our polynomial will factor by grouping. Okay. When you are looking at this system of equations, do not bother with trying to figure out all of the different ways you can factor a times b. That's not actually going to help you do this the shortest. In most cases. In most cases, it's going to be better for the student to look at the sum of 40. We want to produce two numbers, a and b, so that their sum is 40, but their product is 396. And if you don't know exactly where to start with your candidates for A and B, just start at a dumb place, like 0 plus 40. It gets you started. You're saying that here is my candidates for A and B. They add up to 40. The only problem is their product is not 396. So, okay, so you say, well, let me try, how about 1 and 39? That adds up to 40, but 1 times 39 is still not 396. It's bigger than 0, it's 39, but we've got quite a long ways to go here if we're going to get up to 396. At the next stage, I can say 2 plus 38. I'm just adding 1 to get to there, and I'm subtracting 1 to get to there. It's going to still add up to 40, but a 2 times a 38, that's just 76. Right? In the stage before it, we were at 39, and in the stage before that, we were at 0. So you could increment by 1 each time. That would be your smallest incremental step that you could do. You can take larger steps like we're about to do in the next stage. So 3 times 37, that would be 111. So we still have quite a bit of ways to go. I can probably avoid the odd ones, can't I? And just land on the even ones, since 396 is even. So let me, instead of just adding 1 each time to get to the next one, I'll skip a few and add, let's do 3. So I'd add 3 to get to 6, and then I'll subtract 3 from the 37 to get 34. That still adds up to 40. And 6 times 34, that's going to be 204. So it's still growing. We'll know that we have our solutions for A and B trapped if we somehow surpass 396. And I can gauge maybe how far I need to go, kind of not very accurately, but I know that, you know, I'd be willing to bet anything that 8 and 32 is probably not gonna do it, right? So let's just go ahead and jump out to 10. 10 plus 30. In fact, that could have been a nice starting point for you. 10 plus 30 is 40, and 10 times 30 is 300. If you have a little bit of practice with this technique, then this could have been a place for you to start instead of way back here. Okay, well, how about 14 plus 26? That equals to 40. And 14 times 26 is 364. Getting close. 16 plus 24. That's 40. And 16 times 24 is 384. I've got this feeling then like 18 and 22 might just be what we're looking for. 18 and 22 add up to 40. 18 times 22, that's 396. So we can conclude that A should be 18 and B should be 22. Now we come back over to our polynomial minus 12x squared, and we replace the A with the 18, and so there's 18x and 22x, and then minus 33. Okie doke. Factor by grouping says that let's just study these two terms and find their GCF and factor it out of just those two terms. So their GCF is a, let's factor out a minus 6x. And then I'd be left with 2x minus 3. And then this plus sign will be this plus sign. So that comes to right there. And then I will factor by grouping on these two terms. And it looks like I can factor out an 11. The 11 factors out, and what's left over is 2x minus 3. In fact, this must have happened where this and this are identical. If you do this and you don't get them to be identical, you haven't done it correctly. Well, now I have only two terms. Now I have only two terms, and each of those terms has the what in common? It has the 2x minus 3 in common. So the 2x minus 3 factors out, and what is left is a minus 6x plus 11. We have factored our polynomial. Now, how did this happen? Well, if you could imagine what happened when you would have FOILed it out, when you FOILed it out, then you would have gotten something looking like this. And then when you combine like terms, you would get all the way to the trinomial of just 3 terms. And what we did with our system over here was we determined what the polynomial would have looked like after it was FOILed, but before you combine like terms. So that way we could take our polynomial and disassemble it into disassemble that middle term in just a specific way, so that when we factor by grouping, we'd be guaranteed to end up with the same term, with the same factor in each term. And then you can get your final factorization. I mean, look back right here. This is exactly what it looked like after we this is exactly what it looked like after we did the FOIL, but before we combined like terms. And I was able to determine with this method how that would have looked. Okay, great. Let's try one more. Okay, let's try this. By the method of the A's and the B's, we want to find solutions to this nonlinear system such that A times B equals 9 times 25 and A plus B equals minus 50. So the idea of setting up this system, this is not new. I've formalized it here, but this is just a formalization of what people are doing when they solve it by guessing and checking, because ultimately they would like a writing that's configured in such a way down here where when they multiply these two together, they get, when they multiply those two coefficients together, they can get 9, but then they need to also be able to multiply this number and this number together to get 25, and then that's the guessing part, and then the checking part is to see that the sum of the inner terms winds up being minus 50. The part that's different from what anybody else is really doing is, instead of doing a bunch of guessing by looking at different products, I want you to systematically study the sum. That's the unique aspect of this strategy. You can systematically study this sum, and it's systematic because all you're doing is adding 1 to get to the next one. Right? 1 minus 51. That's minus 50. But look, we've got a problem. If we continue going this direction of just adding 1 here and then subtracting here, then I'll always have a product of a positive number and a negative number, which will always be negative. And I'm not supposed to have a times b be negative. A times b is this positive 225. So instead of going this direction, go this way. Where we say minus 1 minus 49. That's minus 50. And the product is 49. Right. Minus 2 minus 48. That adds up to minus 50. But a minus 2 times a minus 48, that's 96. It's growing. Maybe we can skip down to minus 6. Okay, so there I subtracted 4. So on the minus 48, I should add 4. This would be minus 44. That gets me minus 50. And 6 times 44 is 264. Oops, went too far. 264 is bigger than 225. Okay, well, let me just back up 1. And look at minus 5 minus 45. That's minus 50. And wouldn't you know, minus 5 times minus 45, what do we get? You get 225. So A should be a minus 5 and B should be a minus 45. I come back over to my polynomial and I say, I change this minus 50x into a minus 5x minus 45x plus 25. Now you can factor by grouping. From the first 2 terms, all they have in common is an x. Factor it out. You're left with 9x minus 5. From the second 2 terms, it looks like what they have in common is a let me say this first. I kind of always want well, so here's what I want to say. We need to be making sure that what we're left with over here is 9x minus 5. So that will determine for you what you must factor out. What you must factor out here is a minus 5. Because upon redistributing, you can get back to these 2 terms. So a minus 5 is what factors out. Now I have the same factor in each term, so that factor can factor out the 9x minus 5. And what are you left with? X minus 5. Not a single guess and check anywhere.